Hello viewers, today I am going to discuss some energy term and first laws and laws of thermodynamics. First topic is internal energy or intrinsic energy, denoted by U. The energy associated to a substance due to its molecular structure and molecular motion is called internal energy. Energies contributing to internal energy are internal potential energy due to nuclear energy, electronic energy and bond energy, and internal kinetic energy due to translational, vibrational and rotational motion of the molecule. Absolute value of internal energy cannot be measured, किसी substance में कितना internal energy है, but change in internal energy occurring in a process or change in a state is measurable. It is an extensive property, depends on amount of substance in the system, and a state function depends on initial and final state of the system and independent of change in state. जैसे A से B में चेंज हो रहा है तो डेल्टा इक्वल टू यूबी माइनस यूबी, इट इज इंडिपेंडेंट ऑफ पाथ ऑफ चेंज इन स्टेट. A very important line for an isothermal physical process not involving phase transition, delta U change in internal energy equal to 0 or delta U by delta V at constant temperature equal to 0. Enthalpy or heat content divided by H. The sum of internal energy and pressure volume energy, the CV, of a system is called enthalpy. So H equal to U plus CV, internal energy plus pressure volume. This is extensive property and a state function. Similar to internal energy, absolute value of enthalpy cannot be measured, but delta H for a process is measurable. फिर से वही बात है, फॉर एन आइसोथर्मल फिजिकल प्रोसेस नॉट इन्वॉल्विंग फेज ट्रांजिशन डेल्टा एच इक्वल टू 0 और डेल्टा एच बाय डेल्टा पी एट कांस्टेंट टेम्परेचर इक्वल टू. चेंज इन एंथैल्पी फॉर ए प्रोसेस करते हैं, इनिशियल स्टेट 1 फाइनल स्टेट 2. तो चेंज इन एंथैल्पी डेल्टा एच इक्वल टू H2 माइनस H1. H2 के लिए लिखा जा रहा है U2 प्लस P2 V2 और H1 के लिए U1 प्लस P1 V1. After rearranging U2, delta H equal to U2 minus P1 plus P2 V2 minus P1 V1 or delta H equal to delta U plus delta P. At constant pressure, when P1 equal to P2 equal to P. So this equation reduced to delta H equal to delta U plus P V2 minus V1 or delta U plus P delta V. At constant volume, V1 equal to V2 equal to V. Then delta H equal to delta U plus V P2 minus P1 or delta U plus V delta P. For ideal gas, PV equal to nRT होता है, so P2 V2 के लिए nRT2 and P1 V1 के लिए nRT. It is only for ideal gas. The above equations are valid for both real and ideal, but further equations are only valid for ideal gas. So for definite amount of gas means N1 equal to N2 equal to N, then delta H equal to delta U plus nRT2 minus P1 or delta T. At constant temperature T1 equal to T2 equal to 2, the delta H equal to delta U plus N2 minus N1 RT or delta nRT. 1 mole of an ideal gas undergoes change in a state 2 atmosphere and 3 later 2 atmosphere 7 is मतलब constant pressure. With change in internal energy 30 liter atmosphere, calculate delta H. So pressure is constant, so delta H equal to delta U plus P delta V or V2 minus V1. The delta U is given 30 liter atmosphere, T2, and change in volume 7 minus 3, 38 liters. 1 mole of a non-ideal gas undergoes change in state 2 liters, 2 atmosphere, 3 liters 95 Kelvin, 4 atmosphere, 5 liters 245, and delta U is again 30 liter atmosphere. It is non-ideal gas, so we cannot use N2RT2. We use only delta H equal to delta U plus T2 V2 minus T1 V1. वैल्यू पुट कर रहे हैं 44 लीटर. Zeroth law of thermodynamics. If two systems A in equilibrium with B to C and B in equilibrium with C, so A and B are also in equilibrium. Now first law of thermodynamics. It is simply law of conservation of energy. Energy can neither be created nor be destroyed, but can be converted from one form to another form in equivalent amount. So first law of thermodynamics was stated by Dalton and Helmholtz by accepting conservation of energy as principle of universal validity. First law of thermodynamics, energy can neither be created nor be destroyed, although it can be converted from one form to another form in equivalent amount. So net change in energy of a closed system is equal to heat absorbed plus work done on the system. So Q equal to delta U minus W or Q du minus W. For an isothermal process, delta U equal to 0, so Q equal to minus W. For an isochoric process, W equal to minus C delta V equal to 0, so QV equal to delta U. मतलब heat change in a isochoric process is equal to change in internal energy. For QV, V substitute for constant volume. For an isobaric process, W equal to minus C delta V. So QP equal to Q plus C delta V or delta X. So hence for an isobaric process, heat change in a process is equal to change in enthalpy. 2 moles of an ideal gas, ये change हो रहा है A से B. It is isobaric, B to C, isochoric, and C to A, isothermal reversible. So overall cyclic process WAB, isobaric, B to C, isochoric 0, or WCA 2.303 V2 minus V1. Now molar heat capacity. A specific heat capacity is defined as amount of heat required to raise temperature of unit mass of a substance through 1 degree. It's called a specific heat capacity. Similarly, unit mass की अगर हम 1 mole लेते हैं, amount of heat required to raise temperature of 1 mole of a substance through 1 degree. Is called molar heat capacity. If temperature of 1 mole of a substance increases from T1 to T2 by absorbing Q heat, then C equal to Q by T2 minus T1 or delta T. For in gaseous state, molar heat capacity can be measured in 2 ways. Molar heat capacity at constant volume, Qv equal to Q की जगह डेल्टा U लिया जा रहा है, अभी आपने पढ़ा, बाय डेल्टा T और du बाय डेल्टा dt। मोलर हीट कैपेसिटी एट कांस्टेंट प्रेशर, तो Q की जगह डेल्टा H बाय डेल्टा T और dH बाय dt। रिलेशन बिटवीन Cp एंड Cv, H equal to U plus Cv and Cv equal to RT, both equations are differentiated with respect to temperature at constant pressure। dH by dt du by dt plus P constant है, P dV by dt, P dV by dt equal to R। P dV by dt का वैल्यू दे रहा है, तो dH by dt equal to Cp, dU by dt equal to Cv and P dV equal to R, so Cp minus Cv equal to R। For monoatomic gas Cv 3R by 2 and Cp 5R by 2, the Poisson's ratio gamma Cp by Cv equal to 5 by 3 or 1.67। For diatomic gas or linear polyatomic gas Cv 5R by 2 and Cp 7R by 2, so Poisson's ratio gamma Cp by Cv 1.47 by 5। Non-linear polyatomic molecules Cv 3R and Cp 4R, so gamma Cp by Cv 4 by 3 equal to 1.3। Some numerical example, a specific heat capacity at constant volume is there and molar mass is 40. Calculate atomicity of that. Then which I am going to calculate Cv, the specific heat capacity by molar mass is 3 calorie or 3R by 2. It is equal to mol 3 calorie मतलब 3R by 2, so hence gas is monoatomic। Calculate number of atoms present in 11.2 liter gas at Cp, gamma 1.4। Gamma 1 मतलब diatomic, number of mole, molecule 11.2 by 20.8 into N, it is number of molecules and each molecule contains 2 atoms, so number of atoms is twice of it। Relation between pressure, volume, temperature for adiabatic process। For adiabatic process Q equal to 0, then D equal to W और du की जगह Cv dt और W की जगह माइनस Cv और C इक्वल टू RT बाई G दे रहे हैं, तो Cv dt बाई इक्वल टू dt बाई T एंड R dV बाई G। R बाई Cv करते हैं, तो Cv माइनस Cv इक्वल टू R, दोनों और Cv से डिवाइड करते हैं, तो R बाई Cv इक्वल टू गामा माइनस 1 होता है, ये Cv इधर आ गया, तो dt बाई T इक्वल टू माइनस गामा माइनस 1 ऑन इंटीग्रेशन dt बिटवीन टू लिमिट ln T2 माइनस T1 ln V2 माइनस 1 मतलब माइनस गामा माइनस 1 और T2 बाई T1 ln V2 बाई V1 के V1 बाई V2 साइन पॉजिटिव कर रहे हैं गामा माइनस 1, तो V1 गामा माइनस 1 इंटू T1 और V इक्वल टू V2 गामा माइनस 1 T2 है, V1 गामा माइनस 1 इंटू T2 कांस्टेंट। नाउ T1 की जगह आप हम दे रहे हैं P1 V1 बाय R एंड T2 या T2 V2 बाय R, सॉल्व करने का P1 V1 गामा इक्वल टू P2 V2 गामा, तो PV गामा इक्वल टू कांस्टेंट। नाउ V1 की जगह दे रहे हैं R T1 बाई P1 V1 की जगह, अब V2 या R T2 बाई P2 सॉल्व करने का P1 1 माइनस गामा T1 गामा इक्वल टू P2 1 माइनस, ये रिलेशन है। वर्क डन इन एडियाबेटिक प्रोसेस Q इक्वल टू 0, so W इक्वल टू du और फॉर n मोल C एन CVD, D इक्वल टू CVD हम यूज करते आ रहे हैं फॉर 1 मोल एंड फॉर n मोल C एन CVD ऑन इंटीग्रेशन बिटवीन टू लिमिट T1 टू T2 W इक्वल टू n CV T2 माइनस T1, CV इक्वल टू nR गामा माइनस 1, जस्ट यहाँ हम लोग यूज किया है। CV इक्वल टू R R gamma minus 1. So it is NR gamma minus 1 P2 minus T1. P2 भी दे रहे हैं P2 V2 minus by NR P1 V1 by NR. So final formula W equal to P2 V2 minus P1 V1 equal to gamma minus 1. 0.4 mole of monoatomic gas placed in a container of 1 liter and pressure 1 kPa. It is expanded reversibly and adiabatically pressure becomes 0.1 kPa. Calculate final volume and work done. तो P1 V1 इक्वल टू P2 V2 गामा मोनोएटॉमिक है. P1 P2 इक्वल टू V2 बाई V1 गामा. log P1 बाई इक्वल टू गामा V2 बाई V1. तो log V2 बाई 1 बाई गामा log P1 बाई P2 वैल्यू दे रहे हैं. तो V2 बाई V1 इक्वल टू comes as 4 and V2 इक्वल टू 4 and W P2 V2 minus P1 V1 इक्वल टू ये वैल्यू दे रहे हैं. तो वर्क डन हो गया. Now work done and same change in volume. If initial state and final state are same, then work done. Area under the graph isobaric के लिए सबसे ज्यादा है, then isothermal, then adiabatic. तो isobaric is then isothermal, then adiabatic. Now Joule-Thomson effect. It is not in syllabus, but for advanced purpose, when a real gas is allowed to expand adiabatically in vacuum or in a region of very low pressure, below inversion temperature. एक टेम्परेचर होता है इन्वर्जन टेम्परेचर, वही 2A/RB होता है. यदि temperature of the gas decreases, cooling effect, like CO2 at 298 Kelvin. And above inversion temperature of gas increases like H2 at 298 Kelvin. This is called Joule-Thomson effect. And Joule-Thomson coefficient mu Jt equal to del dT change in temperature by change in pressure at constant enthalpy. So ideal gas mu Jt equal to 0. Below inversion temperature mu Jt equal to dT और dT दोनों negative इसलिए becomes positive better than 0. And for real gas above inversion temperature dT positive and dT negative, so it becomes negative. And that's all. Thank you. Subscribe the channel and press the bell icon for proper notification. You can share this channel with your friends.